Hey guys, so in this video we're going to be looking at what an isotope is. Just a big idea. So let's first look at the definition. So an isotope is a nuclear species of the same element that contains the same amount of protons but a different number of neutrons. Now let's go back a little and let's remind ourselves what a proton, neutron, and neutron is. So the proton and the neutrons are both subatomic particles that we can find in the nucleus of our atom. And our proton is going to be our positive charge, and neutrons are going to be neither positive or negative. They are going to be neutral. So our protons and our neutrons are what add up to make our atomic mass, and this is going to play a huge role in isotopes. So what's the change? Like, what happens? Because we know that number of protons stay the same, but the number of neutrons changes. So this causes a change in our atomic mass, like I was saying. The number of protons plus neutrons equals our atomic mass, right? So if we're going to change the number of neutrons, then obviously our atomic mass is also going to increase or decrease by the number of how much our neutron has changed, right? So we'll go more into that later. So let's look at the causes. How is an isotope formed? We have a normal element, let's say carbon, and its number of neutrons changes. How is that possible? So there's two causes. One, naturally. That is through radioactive decay. Radioactive decay is the release of energy in the form of ionizing radiation and through alpha, beta, or gamma decay, and you should have learned this in physical science. So this is a natural way it occurs, but there's also an artificial way that you can cause a change of neutrons, and this is formed by artificially bombarding a stable nucleus, right, where protons and neutrons are, with charged particles through accelerators or nuclear reactors. Okay, so now let's look at an example, radioactive carbon-14, which we will look at in the next video. See you then!